let's have a quick refresher on stretching or compressing graphs of relations. Okay, if you remember, we covered this in depth again before spring break. Let's assume A, B, and C are constants. Okay, I'm going to assume both A and B are positive for now. Okay, here's a quick thing I want to note. Note this: if A is greater than 1, then its reciprocal is going to be less than 1. For example, if A is 7, 1/7 is less than 1. Okay, this is going to be important later. Okay, however, what? If A is between 0 and 1, then its reciprocal is greater than 1. For example, suppose A is 1/7. That's between 0 and 1. Its reciprocal is 7. That's certainly greater than 1. Okay, so you guys can contemplate that just a little bit here. Let's go ahead and fill in the blanks here in this particular question. Let's assume that A is greater than 1, and the graph of f of ax comma y equals c is the graph of f of xy equals c. Remember how it works here? This is what? Compressed by a factor of 1 over a in the x direction. Okay? Sorry about that. Had to let the cat out. Anyway, now let's assume that what? A is between 0 and 1. The graph of f of ax comma y equals c is the graph of the original function. I'm thinking f of xy equals c. What? Stretched by a factor of 1 over a, again, the reciprocal in the x direction. Now, to know whether it's compressed or stretched here, think about the factor 1 over a. Now, originally I had what? A is greater than 1, so its reciprocal is what? Going to be less than 1. So that's what I'm getting, a compression. Okay? In the second case here, where a is between 0 and 1, then what? Its reciprocal is going to be greater than 1, therefore it ends up stretching the graph. Again, this is only in the x direction because I've what? So far I've only monkeyed with x. Okay, let's take a concrete example of this. Okay, suppose I'm considering how the graph of 4x squared plus y squared equals 9 is related to the graph x squared plus y squared equals 9. By the way, if you think about this, x squared plus y squared equals 9, you guys can see what? That is the circle centered at the origin with radius 3. Okay, how does this guy compare to that? Okay, let's go ahead and do this. The first thing I'm going to do here is I'm going to start with this one, right? I'm thinking this is my original, and this is the one that's messed up here. Okay, now when I'm looking at x squared plus y squared equals 9, I'm thinking of what? This is my function of two variables. That's f of x, y. Okay, and then my constant c on the other side happens to be 9. But it could be something else. It wouldn't matter. Okay, f of x, y equals 9. Now, I'm thinking that is my original. When I come over here and think of this, though, again, exactly the same c, and I'm looking at this in terms of x, or f, I'm sorry. What have I really done to get there? Well, here's the idea. You guys see that this is just the sum of two squares, x squared plus y squared. Here, if I want to think of this as a sum of two squares, I've really got this, don't I? Wait a minute. I've really got that. That's actually 2x squared, the whole quantity squared plus y squared. So if this is actually, can you see, f of 2x comma y here. Aha. So if we hark back to what we did here previously, then what I'm looking at is what? A is equal to 2 is what it looks like. A is equal to 2. So if A is equal to 2, that means what? I'm actually, take its reciprocal. The reciprocal of 2 is 1/2. That's a compression. So here's what I'm going to do is say this. So I'll make this as a sentence here. Is the graph of blah, blah, blah compressed by a factor of its reciprocal here of 1/2 in the x direction. Alrighty. All right, let's go ahead and do a second example. The graph of 1/16 x squared plus y squared equals 9 is the graph of x squared plus y squared equals 9. What? Okay. Once again, this is my original, x squared plus y squared equals 9. So just like up here in the previous example, my f of xy is x squared plus y squared. Okay? So let's think about if that's true, how do I get 1/16 x squared plus y squared in terms of that function of two variables, f? Okay? Do you guys see that 1/16 x squared plus y squared would actually be what? 1/4 x squared plus y squared. So that is really the function f at what? 1/4 x comma y. So once again here, maybe I should write this explicitly this time. You see that factor that I'm multiplying on x, which I've been calling a, that's 1/4, right? So when I'm considering whether it's a stretch or compression, I need to take its reciprocal. 1/a is 4. Ooh, that's greater than 1. So this is going to be a stretching in the x direction. So it's the graph of blah, 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 stretched. Some people would say dilated. There's other things you can call it. Stretched by a factor of 4 in the x direction. Okay? Now, the next thing I'm going to do is go ahead and graph these on Desmos so you can actually see this happening here. You might try that yourself first, but let's do it here in a second. Okay? Here we've got the relations graphed in Desmos here. If I come up here, x squared plus y squared equals 9. You guys all know, like we already said this, that's what? The circle centered at the origin with radius 3, so you guys can see that there. Okay, let's maybe take these other two off here for a sec. Okay, there's the original. Then what? Let's look at this second one here. That was where we had what? 4x squared plus y squared equals 9. We were saying what? That would end up being a compression by a factor of 1/2 in the x direction. Let's go ahead and sort of see that there. It does look compressed, doesn't it? And there's its x-intercept here. This is a good way to see the compression. And, oh, yeah. You guys notice the x-intercept over here on the right for the circle was what? The original circle is 3, 0. The x-intercept here over on the right for this critter is what? 1.5, 0. It's been cut in half. By the way, I don't know if you know the name of this thing, okay, this curve here. This is actually called an ellipse, okay? Well, it seems to be working here. Now let's take this guy out here. Let's go to this other one. You guys see where we've got the factor of 1/16 sitting out in front of x squared, okay? Oh, okay. We said what? Let's take the x-intercept here. We predicted that would be what? A stretching in the x direction by a factor of 4. So I'm figuring this better have what? X-intercept of 12. Okay? Yep. 4 times as much as 3. 4 times 3 is 12. Okay? This is also an ellipse, by the way. But there you go. There's examples of stretching and compressing in the x direction. Okay, we want to take a look at another problem here. Notice in this particular question, I'm actually starting out with x squared plus y squared equals 16, which is what? The circle centered at the origin with radius 4 this time. And this time you got to notice that I'm messing with both the x and the y. Now, the stuff I said in the beginning about when I take a positive factor on x, the same thing applies if I start taking positive factors on y as well. For example, if I had just messed with by here, this would be compressed or stretched by the reciprocal of whatever b is. Okay, so keep that in mind when we work this problem. Okay, so here you guys notice my f of xy this time is x squared plus y squared, just like last time, as a matter of fact. But c is now slightly different. It's 16. Doesn't matter all that much here as far as the action, what we're interested in here. Now, when I'm looking at 1/9 x squared plus 4y squared, the function f of xy is just the sum of the squares there. I want to see this as a sum of squares. And you guys notice that that's going to be what? 1/3 x squared plus the quantity 2y squared. And that is really what? X has been replaced by 1/3 x. So this is really f evaluated at 1/3 of x. Instead, y has been replaced by 2y. So we're looking at what? F of 1/3 x comma 2y. Our a here, the factor on x, is 1/3. That means what? It's reciprocal. 1 over a is 3. That's certainly greater than 1. Therefore, we're what? Stretching in the x direction. Our factor on y is b. b is 2. 1 over b is a half. That's less than 1. Okay? So it looks like we're getting a compression in the y direction. So let's go ahead and finish out this sentence here. This would be what? Stretched by a factor of, let's see, what was it, 3? That's the reciprocal of a in the x direction. And compressed by a factor of 1/2 in the y direction. Now, when I ask you guys questions like this on quizzes and stuff, you want to be able to what? Know what these factors are, and you also, whether it's stretching or compressing, and also what? Which direction it's in. Okay, so you've got to have all those elements involved in your final answer. Okay, just a quick Desmos graph of the situation. There's the circle we were talking about, x squared plus y squared equals 16. Center is at the origin. The radius is 4, as you can see. Here is my other curve here, 1/9 x squared plus 4y squared equals 16, an ellipse actually. And we predicted what? That this would end up being a stretch in the x direction by a factor of 3, and you can see that by the y-intercepts. We also predicted that this would be what? A compression by a factor of 1/2 in the y direction, and once again you can see that as well from the y-intercepts there. So everything's working just like we thought it would. Alrighty.